Last up for section 9.1 is going to be topic 4, which is on the bearing of an object. This is weird. It's a little bit new. I mean, it's potentially very new for some of us. Pilots might use it, people in boats might use it. It's not something I ever intend to use other than when I teach it. I'd say don't overthink it. That would be my tip for you. I can't remember if it comes up again. I was talking to somebody today and they said it comes up in physics, but you approach it differently where you use these things called vectors. I'm not sure if we're gonna do this again because we will talk about vectors in the next chapter. But I'm not sure if we talk about this in that regard. But you may see this in a physics class depending on what you're taking. Okay? So it says in navigation and surveying, the direction or bearing from point 0 or O, I'm going to call it O for origin, but the bearing from point O to P1 is denoted by N 30 degrees E. Okay, what the heck does that mean? Indicating that the bearing is 30 degrees east of north. Okay, that makes sense. In writing the bearing from O to P, the direction north or south always appears first, followed by an acute angle. So keep in mind it has to be an acute angle, followed then by east or west. Okay, so there is kind of like a rhyme or reason to this. North or south first, the acute angle, and then followed by an east or a west. Okay, so if we kind of think about this, we've got our point O, which we're going to think of as like the origin. So that's right here. Okay. Well, north is going to be directly above that. That kind of makes sense. We're familiar with north, south, east, and west. Okay. So what's happening to get to this point P1 is, well, we're going north and then we have to kind of fall. Okay. So we're kind of falling over here. Can you see this red line? We're kind of falling to the east 30 degrees. Okay. And so that takes us to this point, which we would then say has a bearing of north 30 degrees east, which just means that this point is 30 degrees east of north, okay? So this is 30 degrees east of north, okay? So let's answer just a couple of quick questions about this, and then we'll do one word problem. I think it's just one word problem, okay? So example 6 says, use the figure above to answer the following questions. Part A, what is the bearing from O to the point P4? Well, O is the same origin, okay? So we're now interested in P4 right here. Okay. Well, what would the bearing be? Well, we're definitely south. Okay. So you always kind of find your origin, whatever that is, whatever it's labeled as, and you're either going north or you're going south. Okay. And then you're going to have to figure out, okay, from south or from north, am I to the east or am I to the west, and how many degrees? Okay. Well, in this case, we are definitely east of south. Okay. P4 is definitely to the east of this south direction from, our origin O. Okay. And we are told that it is 20 degrees east. Okay, so we would say the bearing here is south 20 degrees east, which just means we are 20 degrees east of south in relation to that point O. Okay, now part B says describe what is meant by the notation north 70 degrees west. Well, this just means we are 70 degrees west of north in relation to that point O. So you kind of have to have like this origin. So you're thinking like kind of think of this like the Cartesian plane. So we have our Cartesian plane, we have the origin directly above that is north, directly below that is south, and then directly to the right is east, directly to the left is west. Okay. So we always start from the origin. Are we north or are we south of that? And then are we to the right, which would be east, or are we to the left, which would be west? And then to the left or right, how many degrees, very specifically. And your angle has to be acute. Okay? So that is just a really quick overview of bearings so that we can do this really cool problem. And I'm going to switch from red to black. Okay. So example 7 says solve, whoops, and it says include a diagram or drawing with your solution. With these problems where you're doing the bearing, you need some kind of picture. I don't want to say you have to have one, but you're probably gonna have to draw something to kind of figure out what's going on. So be ready to draw your diagram. And what I would do when you're doing a problem that involves bearing, just start with the north, south, east, west. So kind of draw like the XY plane, okay? And label your north, your south, your east, and your west. Okay, so north, south, east, west. Okay, start with that. All right. So it says a Boeing 777, 777, 777, 777. I don't know what you call it. I'm familiar more with like a 747. Is that a thing? Anyway, so some kind of aircraft takes off with a bearing of north 20 degrees east. After flying for 1 mile, the pilot of the aircraft requests permission to turn 90 degrees and head towards the southeast. Okay, the request is granted. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the aircraft? So we take off, think of that as being like the origin, like where are we starting? So we're going to start at the origin. Okay. And our plane is going to take off, and they're going to take off with a bearing north 20 degrees east. Okay. So basically, imagine you're going north. Let me actually draw this in red. So imagine you're going north. Okay. But you have to fall, okay, in the east direction 20 degrees. And that takes us here. And so the plane right now is chilling at this point. Okay. Now we know that this angle, let me scoot it down just a little bit so I have plenty of room. We know this angle measure was 20 degrees because we were told that the bearing at takeoff was 20 degrees north or north 20 degrees east, which means they were traveling 20 degrees east of north. Okay. And they did this for 1 mile. Okay. Now, after a mile, the pilot requests permission to turn 90 degrees and head towards the southeast. Well, the southeast is going to be down and to the right, okay? So they're going to go exactly 90-degree turn and they're going to head southeast. So this is pretend that's exactly a 90-degree turn, okay? So they turn 90 degrees, they head southeast, and they do this for 2 miles, okay? This is most definitely not drawn to scale, pretend. Okay, so the request was granted. They turn 90 degrees. They're heading southeast. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the aircraft? Well, let's figure it out. So what has happened is we've created a right triangle. Okay, we know this right here is 20 degrees. Okay, we were told our bearing, remember, was north 20 degrees east. So that's what's going on here. Okay, so that little angle measure from the what would be kind of like the y-axis, let's call it the north axis, to this line of travel, the initial line of travel, that was 20 degrees. Okay, we've created this triangle right here. What we need to do is we need to figure out this angle right here. Okay, because essentially what's happening, and let me draw this in another color. Essentially what we need to do is we need to know this whole angle. Okay, what we have so far is 20 degrees of it. We still need to find this blue piece. Okay, and do we have enough information for that? Well, we have a right triangle. We know that because the pilot was going straight, whatever direction, and then they made a 90-degree turn. So we have a right triangle. We have this angle right here in blue. Let's call it alpha. I don't care what we call it. We'll call it alpha. So if we're considering alpha, we have the side adjacent to alpha and we have the side opposite of alpha. So if we use tangent, we can find this angle. Okay. So tangent of angle alpha is going to equal the side opposite, which would be the 2 miles, divided by the side adjacent, which would be 1 mile. So we're looking for tangent of alpha equals 2, and crud, what do? Well, luckily, in the previous, I don't know, like 2 examples ago, 2 videos ago, we talked about solving these right triangles using inverse trig functions. So we know that if we take the inverse trig of both, or the inverse tangent of both sides, we can eventually solve this. Well, the inverse tangent and the tangent, they just kind of unravel each other, and what we're left with is alpha, and alpha equals inverse tangent of 2. So let's figure out what inverse tangent of 2 is. So we go to the calculator. You definitely want to make sure you're in degrees here. Okay, so I know I'm in degrees, make sure you are. And we want to go second tangent, and we're going to plug in a 2, and we get 63. Let's go 2 decimal places, so we get 63.43 degrees. Okay, so what is that? Well, 63.43 degrees is this blue part of the angle. But that doesn't really tell us the bearing of the plane because remember, going directly north, we had to fall 20 degrees to the east, and then we've not fallen, but we've sort of fallen another 63.43 degrees. So what we need to find is this entire angle now. Okay, we need to find this entire thing. Okay, so that entire angle, we had the 20 degrees that we started with. Okay. We need to add the 63.43 degrees that we just found for this triangle that we created with our path of flight, which is 63.43 degrees. So this gives us 83.43 degrees, but we haven't really answered the question. We're like this close, okay? The direction says, or the question asks, what bearing should the control tower use to locate the aircraft? So from the origin, remember our origin here, we've got our plane right here. We're just going to use a star because I don't know how to draw an airplane. What is their bearing now? Well, they're still north of the airport and they're still to the east, but how many degrees? We would say that they are north 83.43 degrees east. So this means they are 83.43 degrees east of north, which is kind of like awkward to say, but that's what's happening here. Okay. You'll definitely see another bearing problem in your homework. There's probably one in your quiz. There's definitely another one in one of the other sections, 9.2 or 9.3. And then I really don't remember if it comes up in chapter 10 for us or not, but there you have it. That's bearings. I try not to make it too difficult. Hopefully that was palatable. Let me know if you have questions.